All right, so today we're going to go through our function challenges that we went through in class. And again, functions are like little recipes or instructions for to do a task. And usually they're a template. So if you imagine I'm making chocolate chip cookies, but I want to swap out chocolate chips for butterscotch chips, as long as I'm entering the same amount, I can alter those values or by changing parameters. So in this case, parameters. We're going to start just by writing all of our function structures. So it starts with a def. What does it do? In this case, it's going to calculate power. And I'm just going to do that through all of them. So hold with me. Something like that. So in our first one, I'm going to need two arguments. So it says needs two parameters, units of work over time. And I can either print work over time or I could have returned it work over time, in which case I would then print this. Because if I'm returning a value, in this case it's a decimal, then I print that out. So those are doing the same thing, more or less, and it's up to you, in this case, how you choose to do that. So as long as you're seeing the values, again, the 5 goes into work, then I see that works like that. So that was our 4.2. So we're going to skip, just like we did in class, I'm going to skip down to 4.4. So in this case, I want to check two conditions. Is the first value greater than the second? And then are both even? So I need to check two different numbers, number 1 and number 2. If number 1 is greater than num2, print true. Else, print false. Test that just with our first condition. 10 and 2, and let's create another one. 20. True, false. Perfect. Then the next condition, it says, are both even? And to check even, we're going to say if number 1 mod 2 is equal to 0, so when divided by 2, there are no decimals, or sorry, no remaining values. And number 2 mod 2 is equal to 0, then print true, otherwise print false. And you might have another else here, else print false. But what we did in class, and which totally makes sense, is if we're already seeing a compound condition, like this is one condition, true or false, and this is already a true or false, we can merge this if with the if above. And I can say, if it's even, and 1 is greater than 2, then print true, otherwise print false. And so I can get rid of that, and I can merge them all together. So this is one condition greater than, this is one condition equal to, one condition equal to. If this and this and this, all three are true, print true, otherwise print false. So it is 5, and then we'll do one right now. It's going to be false and false, or sorry, true. 10 is greater than, and both are even, so true and false. Great. I can do 21, and that's another false. Okay. Then we go to 4.5. 4.5 says take a string and reverse it. We talked about this in class today, that when we look at lists, let's just do an example. My list is equal to, 1, 2, 3, 4, 5. I can print my list forwards, right? Print my list. And I see my list. I can print individual items in my list. Right? What is the second item? 3. I can print from the beginning, from the third item to the end, 2, 4, 5. Or I can say from the beginning to a certain item. Okay. Or I can say the entire thing. What I can also do is what's called steps. So 1 is every item. 2 gives me alternating starting at 0. If they're even in index, do that every third item. So that's the first, and then the third. Or 0 and 3 divisible by 3. What I can also do is a -1, which will reverse it. And I can do that with lists. I can also do that with strings. So in this case, I want to take a string and I want to reverse it. Print my argument s from the beginning to the end backwards. So now I call my string rev of hello. All right, cool. That printed it backwards. Cool. That makes sense. That's working how I expect. And I know that this is reversing. So what I can do down here on my palindrome check, 4.6, is check to see if the string backwards is equal to the string forward. And let's run some tests. Palindrome. So I'm expecting false, I'm expecting true, I'm expecting false, I'm expecting false. False, true, false, false. Perfect. But we think that actually these could be palindromes if they were lowercase. So let's do s is equal to s lowercase. So now lowercase, race car is equal to race car. True, true. I can also take out the space. Replace my space with an empty string. So now I see false, robot is not a palindrome, race car true, top spot true, race car true. Great. So that was that one. And this is kind of the order we went through in class. Then we came up here to FizzBuzz and we talked about the game FizzBuzz. So the way FizzBuzz works is it takes a range, and say we're going to play up to 100. So I can just, let's say first, print upper bound. Let's build this iteratively. So FizzBuzz of 100 prints 100. Perfect. So now we want it to print every item up to 100 for I in a range of upper bound. Print my iterator, I. Okay, that worked. It started at 0, and it doesn't include 100. So went to 99, but not 100. So let's do from 1 to upper bound plus 1. So now it goes 1 to 100, and I'm just going to lower this so we see all of our numbers 20. Great. And that went through and did exactly kind of what we expected. I want every item as it is. So in FizzBuzz, if it's fizz, if it's divisible by something else, or if it's divisible by something else, otherwise, print the number. Okay, so now the question is, what are these conditions? Let's do this. If my iterator mod 3 is equal to 0, meaning it is divisible by 3, print fizz. And then if it's divisible by 5, print buzz. And if it's divisible by both, if I is mod 3 is equal to 0 and I mod 5 is divisible by 0, print FizzBuzz. All right, so let's run that and see what happens. Okay, so 3 gave me fizz, 5 gave me buzz, 6 gave me fizz. That all looks right. And then I got to 15 and it said fizz. Because if my condition is met, which it is, 15 mod 3 is equal to 0, then it is fizz. It never checks this. My condition is met before the condition I was expecting. So we need to flip these in order. So if my thing is mod, this is FizzBuzz, then if this mod 3, then just write fizz. 15 FizzBuzz, that looks correct. So again, because this condition is met, then it does this, and I want it to go through all of these. This has more complexity. It needs to occur before. This has less items that will meet that requirement. It should go before. The same way the grading of is 85 greater than 70. When I actually meant 85 greater than 80, I should go 90, 80, 70, F. Same idea here. So I got to do that. You could also say here that is I mod 15 equal to 0? Because if it's divisible by 3 and 5, it is also divisible by 15. Same, it's going to do the exact same thing. Okay, so that's FizzBuzz. And again, I could do this up to, you could do it forever, right? It's going to go through and calculate and go through and get all the way up to however long it takes, and it's going to tell you if it's divisible by, and it's running through all of these checks every single time until you tell it to stop. All right, so that looks great. Let's go to the next one. So we've got power, that looked great. We've got FizzBuzz, that looks great. We've got our comparing numbers, again, 3 conditions to check, all of that looks great. Our string reversed, our palindrome checked. Again, we made some modifications to make sure our palindrome is flattened or like lowercased, and we've taken all of our spaces out so that things like top spot could work, or sentences that we know that are a palindrome, you could do that. All right, so we're about to think about our other lists. The last one we wanted to do before that is taking a zip code and getting the parts. Again, yes, last week we did this like this. Add them all up. And first I want to see what they are. First, second, third, fourth, fifth. You could, and we'll talk about this here in a second, you could absolutely index them like we did with our palindromes using list slicing. You could also do zip code for divide by 10,000. And then mod 10, do this through, copy, mod 100, mod 10, and then the last one is just mod 10. There we go. And I want to test by printing these before I confirm this. Zip addition 27516 7514. Great. See, that's not going to work. Let's do 90210. Okay. So I'm going to do that. I see them all printing out, so now let's add them together and see if that works. Plus, plus, plus. Great. Cool. And then we talked at the end of class that there's ways that you can do this using some of the concepts that you did in some of your data camps, where we take list comprehension. So I want to go through a list, and for my entire list, let's do First, let's just take zip code as a string. My item gets put in there. Okay, so that looks like a number in a list. And I want to convert it to a string. Now my string is in my list. I have a list of a single item that is a string. And then what we wanted to do was go through for each item in our list. I for I in string. So now these are all broken. We broke our string into individual items. That looks right. Then we convert them to integers. So instead of them now being strings, single character strings, they're numbers. And then I can wrap this all in a sum. So all of these things to get every item into my position could be done with this single line of code where I've taken a number, cast it as a string, gone through a loop. Every item in my loop, I'm converting that item to an integer. They're in a list, and then I sum up that list. So again, a couple different ways to get there. And as we get further along, we're going to try to find simpler, more direct ways of doing it than mod and floor division. But that is how you could get each individual character, confirm that you've got every character, and then add each of those characters together. All right, so let's look for what we still need to do. We've got our fizz buzz. We've got our comparing. Those look great. We want to reverse our string. So I'm going to take a value. Let's say string, and I want to reverse it. Let's do just like we did before. We'll test it with phrase rev. So that's giving us literally the exact same thing we have above, right? But now I want to split this up. Split. So now each word is split by space. That's what the split does. And it presents it backwards. So if I take out this for now, split would just take it, this is APCSP. Backwards inverts my list. And then if I wanted to print this out, I could use a space join every item in my list, add a space, and it prints it out this way. CSP, AP, this is this. If I wanted to make even that scrambled, I could do from the beginning to the end -1. So now every word backwards, each word is inverted, and then the sentence is inverted. So this is APCSP. And that looks great. CSP, AP is this. And I can test it with whatever else I want, right? Hello world. It says world hello. Cool. So I've taken my sentence backwards. Palindrome, we looked good. All right, so now we've got a list of names. Let's say names is my list. I'm going to turn it into a list, brackets. And I want to take something, a list. We'll just say L for list. And I want to return it sorted. So print sorted is how you sort a list. And let's take it with name. So comment this out for a second. And I say name sort of our names. Prints them out like that. Cool. If I wanted to do the same idea, but I want to sort by length, print sorted. And sorted, if we look at our our documentation here for a sorted. Sorted also has a key that you could do, which is going to be key of, and we see what are the different keys, and one of our keys can be length, and key of length. Let's test that. Name sort len of names. It says, gives us an error here. L, sorted L. Okay, length is expecting. So I got to have my argument here. There we go. So my argument gets included. What am I passing? Names becomes my argument or my parameter. It gets plugged in here. It is sorted by the key of length. And I can see that's sorted. The shorter word is Adams. Washington is a longer, and so and so. Okay, so that's the first part. Gets us sorted alphabetically, J, M, W, and then sorted by length. Great. The next one says take a list. Let's take our list here again. And of numbers here. And again, I'm going to take a list, and it says print the largest number, the smallest number, and then the averages of the list. So print, we guess that the biggest item in my list is going to be a max of my L. Print the min of my L. And then to get mean, we're actually going to need to do either one of two things. We can either do import statistics from statistics, import mean, or I can say import numpy as np, and we can do mean in two different ways. So you can either do print mean of L, or I can do print numpy dot mean of L. Those are going to do the exact same thing. And then get the items in my list. List values is my function of my list. So that's my max, that's my min, that's my mean, and my mean. So depending on which one you want to use, numpy or statistics mean, that's how you can get that. You could totally get what is using built-in functions, right? I could do print the sum of my list over the length of my list and not incorporate these at all, right? You can get the average is the total over the count. So those are three different ways to get that value. And in this challenge, that was the goal. Again, print the largest, print the smallest, print the average of a list. If I gave you different lists, right? It's still going to be able to find those same values regardless of what that is. If I, instead of putting my list like this, came down here in my list values of my list, it's going to be able to do the same idea with those values. And that's the goal for today. And I think that is a good way of understanding how functions work, how to define a function, how to call functions a number of times, and making sure that you're seeing your code, because if you're not seeing your code, you're just typing. All right, thanks.